Assalamu alaikum students. Our next theorem is if f is a differentiable at x is equals to c and f dash of c is greater than 0, then f is strictly increasing in some neighborhood of c. In this theorem, they give us if the function is differentiable at x is equals to c. That means we have an interval and the function is differentiable in the interval and also at a point c, and the derivative at that point c in the interval it is greater than 0, then f is strictly increasing in some neighborhood of c. First of all, we have to know that what is the strictly increasing of a function. If we have 2 points from the interval, let's suppose x1 and x2, and if x1 is greater than x2, then f of x1 is also greater than f of x2, then we say that the function f is said to be strictly increasing. That means if a point is greater than the other point, then the function the value of the function is at that point is also greater than the other point. Now we have the condition in this theorem, the derivative of for the function at a point c is greater than 0, so we use this condition. So as we have f dash of c is greater than 0, by the formula of the derivation we write here as limit h approaches to 0 and f of c plus h minus f of c over h is greater than 0. So we write here as, if we skip the limit, that f of c plus h minus f of c greater than 0 and over h. Here students, we see that if the whole value is greater than 0, then it must be have the same sign. That means if we have to get the value is greater than 0, that means the value is positive, then it must be the numerator and the denominator must have same sign. That means if this value have positive sign, then also have h is also is a positive, have a positive sign, and if h is negative, then this value is also negative, because if the both are negative, then it make the value is greater than 0. So we write here as both the values here both the values h and f of c plus h minus f of c, the whole value, must have the same sign. So both have the same sign. Then if we have to assume that what is the h? H is a very small value, but it is maybe a positive or a negative value, where h is very small. It tends to 0, not with it not must be not it not must be 0. So it tends to 0, that means it was very small, but it is not restricted that it is a positive or it is a negative. So we here we define it as the age is must be between the two numbers like that minus epsilon less than h, and h is less than epsilon because the h is very small, but we have not defined that the h is a positive or negative, but it is small, so we have a very small value at is epsilon. Here we write is as epsilon is very small, or it also must be greater than 0, and we have an interval. As we see that in the real line, if there is a minus epsilon and epsilon, then there must be 0 in between these values. Then we have also 0 in between these values. If we take this value only, that h is less than epsilon, then how we write as if h is only less than epsilon. Because we have two cases here, so we take the first case that h is less than epsilon. After this we take the other case minus epsilon less than h. First of all, we have to h is less than epsilon. Now what we have that here we have a c, h must not be 0, okay, and h is less than epsilon, that means h is some here, some here, okay, and it not be 0. Then we write here as h is must be greater than 0, okay. Then we write it as uh, h is greater than 0, and we also, if we take this h is less than epsilon, then we reversely we write as the epsilon is greater than h, then epsilon is greater than h. We have this value, and this is for only the h. If we take this value, we assume that the same sign. Then if we have h is greater than 0, we take this h is greater than 0, then we take this is also the greater than 0 value. Then this implies that f of c plus h minus f of c is greater than 0. If this is greater than 0, we have h is some positive value. Yes, we have h is some positive value, because we say that the h is must may be negative or positive, but in this case when we take h is less than epsilon, then it must be positive value. So h is for some positive, then if we added some positive number to c, then what is c and the c plus h, the relation between c and c plus h? If we have a point c and we added some very small positive number in c, then we have c plus h is must be greater than c, okay. And why this is also greater than c, and we find that f of c plus h is greater than f of c. Here we have the point c plus h is greater than c, and we also have the function c plus h is greater than from f of c. Then we have the definition of strictly increasing of the function. If we have 2 points, one is greater than the other, and the function value of that point is also greater than the other, so we can write here as, so the function by this condition that h is positive or h is less than from epsilon, then it must be strictly increasing. This implies that f is strictly increasing. We also write here as h is positive, sum of here. Then now we have the other case that we discussed before, that we have the case is minus epsilon less than h. Then we also find, because we have to find we have the here that the h is not must be positive, because h is must be, may be negative or positive. So for the negative case, minus epsilon is less than h. So minus epsilon is less than h. That mean the h is in between here. Okay, because now the h is not positive, now the h is negative. Okay, then that is sum of here, but we also say that the h is not b0, so we take the value from here and write as the h is less than 0 because the h is negative, and from the here minus epsilon is less than h. Okay, now the h is negative. Before we say that both these values have the same sign, so h is less than 0, then this value must be less than 0. So we write here as f of c plus h minus f of c less than 0. Okay, now we also discuss the h with c. We have a point c. Okay, and we added some negative number in c. Then what we have the relation between these 2 points, then c plus h must be less than c because here because here h is negative number. Okay, as we have to be if must for example c is maybe 4, then we minus we write here as if for example c is a 4 and it is must be minus 1, then we added minus 1 in 4, we added right here as 4 and plus in minus 1, and here is 4, then it must be less than 4. So we write here as the another condition is here the f of c plus h minus f of c, and we take this on the other side, then less than f of c, and here the point is c plus h is less than c. Here we repeat again, this h is negative number, is very small, and now the case is that the value of the function c plus h and is less than f of c, because we read our strictly increasing definition in the greater condition, so we write this in the greater condition. As we change this in the case here, we write is here as c is greater than c plus h, and also f of c plus h f of c is greater than f of c plus h. As we have the f of c plus h is less than f of c, then we write here f of c is greater than f of c plus h, and this implies that, and we have the condition again, and we have the definition of the strictly increasing again. Then if the one point is greater than the other, the function value is also greater than the that point, so the function is also strictly increasing if h is a negative number. So this implies that f is strictly increasing. So f is strictly increasing in the neighborhood of c, in some neighborhood of c. Neighborhood we mean that the closing numbers, so we check that in the closing number of c, because the closing number, the change, we see that if the c is here, then we added some additional that mean positive h, then the value is from here, and if we added some negative h, then the values is from the here. So the function is strictly increasing in the neighborhood of c. Then we have the proof.